to truly internalize the reality of the dark matter drift, we must attempt to visualize the universe not as a collection of objects, but as a continuous, flowing topography of density, a landscape where the mountains are invisible and the valleys are deep wells of gravitational potential. The visible universe, the swirling galaxies, the burning stars, the glowing nebulae are merely the snowcaps on the highest peaks of this invisible terrain. If we could switch our perception, trading our electromagnetic eyes for gravitational sensors, the night sky would undergo a terrifying and magnificent transformation. The darkness would vanish, replaced by a blinding luminescence of mass. We would see the great halo of the Milky Way not as a void, but as a towering, brilliant sphere, extending far beyond the disk of the stars, brighter in the center, and fading softly at the edges. We would see the subhalos, thousands of them, moving like fireflies within the greater glow, some containing the tiny sparks of dwarf galaxies, others completely dark, silent wanderers passing through the disk. We would look out into the intergalactic deep and see the filaments not as emptiness, but as blazing rivers of light, connecting the massive, burning nodes of the clusters. In this gravitational vision, the universe is a blindingly bright web of connection, and the voids are the only true patches of dark, deep, spherical caves of emptiness, where the density drops to near zero. In this view, we realize that we have been staring at the negative space for our entire existence, mistaking the shadows for the substance. This shift in perspective brings us to the profound realization of our own intimacy with the dark sector. We often speak of dark matter as something out there, a cosmic glue holding the clusters together, but it is also in here. The drift is local, the phase space of the dark matter, halo, the mathematical description of the position and velocity of every particle, is folded and complex. Theoretical physicists describe the dark matter distribution not as a smooth fog, but as a fine-grained sheet that has been folded over on itself billions of times, like a cosmic origami or the layers of a quasar. This dark matter sheet twists and turns in six-dimensional phase space, and where the folds pile up, where the sheet crashes into itself, we get caustics, regions of infinite density in the mathematical limit, or extremely high density in reality. It is possible, perhaps even likely, that our solar system is currently passing through one of these fine-grained streams or caustics. If so, the density of dark matter in your room right now could be significantly higher than the average galactic background. These particles, ancient remnants of the Big Bang, are streaming through your body at hundreds of kilometers per second. A silent, invisible rain that has been falling for 13 billion years. They are the ghosts of the beginning, passing through the fleeting matter of the present linking your physical existence to the primordial fireball. There is a haunting beauty in the music of this structure. While sound cannot travel through the vacuum of space today, the early universe was different. It was a dense, hot plasma, a fluid where pressure waves, sound could travel. These sound waves were generated by the fight between gravity, pulling the dark matter and baryons inward, and radiation pressure, pushing the baryons outward. These oscillations, known as Baryon Acoustic Oscillations, BAO, rang through the infant universe like a bell. They were sound waves with a wavelength of hundreds of thousands of light years. When the universe cooled and became transparent, these sound waves were frozen in place, imprinted on the distribution of matter. The cosmic web is, in a very literal sense, a frozen symphony. The distance between the galaxies, the characteristic scale of the voids and filaments, is determined by the pitch of that primordial sound. By measuring the distribution of galaxies today, by looking at the clustering of the Sloan Digital Sky Survey or the BOSS data, astronomers are reading the sheet music of the creation. We are seeing the ripples of a sound that rang out before the first star was born. A deep, resonant hum that organized the drift of the dark matter into the harmonic structure we see today. The drift is the physical manifestation of a cosmic song, the silent rhythm of gravity. This interconnectedness extends to a resemblance that has fascinated scientists and philosophers alike. The striking visual similarity between the cosmic web and the neural network of the biological brain. When we look at a simulation of the dark matter filaments with their branching tendrils and dense nodes, and compare it to a microscopic image of a neuron with its dendrites and axons, or a slice of the mouse cortex, the resemblance is uncanny. A study published by astronomers and neuroscientists in Italy quantitatively compared the two networks, the network of galaxies and the network of neurons. They found that despite the difference in scale, one spanning billions of light years, the other mere micrometers, the statistical properties of the connectivity are startlingly similar. Both systems optimize for the transfer of information, or matter/energy, across vast distances with minimal structure. Both systems are complex networks that sit on the critical edge between order and chaos. While this does not imply that the universe is a giant brain, gravity dictates the web, while electrochemical signaling dictates the brain. It does suggest a universality in the laws of self-organization. The drift of dark matter follows the same structural logic as the growth of thought. The universe builds complexity using a dendritic architecture, a branching tree of invisible matter that supports the visible fruit of the stars. Just as the branching structure of our neurons supports the phenomenon of consciousness, we are the thinking matter of the universe. contemplating the structure of the non-thinking matter that mimics our own mind. However, the drift is also a story of fragility. The existence of life, the existence of observers, is deeply tied to the specific properties of dark matter. If the dark matter were slightly warmer, meaning its particles moved slightly faster in the early universe, the smallest filaments would have been washed out. The fine structure of the web would have been erased. Dwarf galaxies would not have formed. The hierarchy of structure would have been truncated. If the density of dark matter were slightly lower, the expansion of the universe might have won the tug-of-war too early. Structures would not have collapsed. Galaxies would not have formed. The gas would have remained a thin, expanding soup, never igniting into stars. We would not be here. This anthropic principle suggests that we observe the amount of dark matter we do, because it is the amount required to build a habitable universe. We are living in a Goldilocks dark matter halo, not too dense to cause frequent, catastrophic collisions that would sterilize solar systems, and not too sparse to allow the gas to escape. We are the survivors of the drift, the beneficiaries of a cosmic tuning that allowed complexity to emerge from the chaos. As we deploy the next generation of instruments, we are moving from the era of mapping to the era of archaeology. The Gaia mission, a space telescope currently orbiting the Sun, is creating a precise three-dimensional map of over 1 billion stars in our Milky Way. It measures their positions and their velocities with such precision that it can detect the tiny wobbles caused by invisible companions. Gaia is effectively weighing the Milky Way, star by star, by analyzing the motion of these stars. Astronomers are reconstructing the history of our galaxy's formation. They are finding phase space structures, groups of stars that are moving together, sharing a common origin. These are the debris of smaller galaxies that fell into the Milky Way billions of years ago, shredded by our dark matter halo. We are seeing the accretion history of our home. We are learning that the Milky Way is a cannibal, a monster that grew by consuming its neighbors, driven by the insatiable gravity of its dark matter core. Gaia is allowing us to see the scars of the drift, the merger trees that show how the dark matter halo was assembled over eons. We are realizing that the smooth halo is actually a messy, turbulent, lumpy graveyard of ancient galaxies, a swirling, chaotic sea of dark currents that is still settling down. The future of this exploration lies in the convergence of the very large and the very small. We are approaching a neutrino floor in our direct detection experiments. Neutrinos, the ghostly particles produced by the sun and cosmic rays, interact so weakly that they usually pass right through detectors. But as our dark matter detectors become more sensitive, they will soon start detecting neutrinos in large numbers. The background background noise will become deafening. Distinguishing a dark matter signal from a neutrino signal will be the ultimate challenge. It represents a boundary of human knowledge, a foggy limit where the known ghosts, neutrinos, obscure the unknown ghosts, dark matter. At the same time, gravitational wave observatories like LIGO and LISA are opening a new window. When two black holes collide, they ripple the fabric of space-time. By studying the distribution of these black hole mergers, we can infer the properties of the dark matter halos in which they reside. We might even detect primordial black holes, hypothetical black holes formed in the first second of the universe, which some theories suggest could make up a fraction of the dark matter. If dark matter is composed of black holes, then the drift is not a flow of particles, but a swarm of holes. A terrifying thought of a universe filled with invisible punctures. Yet, despite the terror of the void and the cold indifference of the physics, the narrative of dark matter is ultimately one of unity. It teaches us that nothing is truly isolated. The galaxy that seems alone in the night sky is connected to us by a 10 million light-year filament of dark matter. The atom in your finger was forged in a star that only formed because a clump of dark matter pulled the gas together. The expansion that threatens to separate us is fought inch by inch by the gravity of the dark sector. We are part of a continuous, majestic flow. The drift is the heartbeat of the cosmos, a slow, rhythmic contraction that fights the dying of the light. It is a reminder that the visible world, the world of politics, of biology, of light and color, is a thin veneer over a much deeper, darker, and more fundamental reality. We are the foam on the ocean, fleeting and bright, while the deep, dark currents move beneath us, ancient and powerful, guiding our course through the void. As we stand at the end of this narrative journey, we must accept that the mystery is part of the beauty. We may find the particle tomorrow, or we may never find it. We may realize that our theory of gravity is wrong, or we may confirm that the universe is filled with a new exuberance of particles we never imagined. But the structure, the web, is real. We have seen its shadow. We have felt its pull. We have mapped its valleys and its peaks. We know that we are drifting. We are not static points in a static box. We are travelers on a great, invisible river, flowing from the fiery density of the Big Bang toward the cold, expanding horizon of the future. The dark matter drifts, and the stars drift with it, and we, the observers, drift with the stars, eyes wide open in the dark, watching the shadows for a sign of the substance that holds us all together.